So we looked at simple interest before. Now let's move on to compound interest. This is the better kind of interest of the two. Now, compounding occurs when interest is earned or charged on previous interest. So the future value of the investment or loan is increasing by a constant percentage R over equal periods. Hence, it's an exponential function. So, we're going to get maybe 4% compounded monthly. So every month we'll get more interest, and the next month after the first one, we'll get interest on the interest we earned the first month, and then we'll get on the third month, we'll get interest we earned on the first and the second month. So it's going to be compounding. And so the future value at time t in years of a loan or investment with a present value p is calculated as, so now we have f of c for compound interest. And so now we have p, our principal, times 1 plus our rate, which is in decimal form, divided by n. This is the number of compounding times it does. So if we have it's compounded monthly, this will be 12. If it's compounded quarterly, it'll be 4. Semi-annually, it'll be 2. Daily, then we'll use 365. And so it all depends on what our compounding rate or time is. And then that's raised to the n times t. And again, that n is the same as that n, and then t is going to be however many years we're going to do this. Now, they say to go ahead and change it to p times 1 plus I raised to the power nt, but then I is r over n, so you still have to type that in. So I favor this formula here, okay? Because then I know I'm plugging in what values, p, r, n, and t, okay? So that's easier for me to remember, okay? And so that's the equation we use for compound interest. So let's look at this example here. So we have investment of $4,500 with an APR of 3.9%, and quarterly compounding would grow to a future value of what in 7 years? Well, what do we have? Well, 7 years is how long it's going to be, so that's going to be our time. Quarterly, that's our n, so that's going to be 4. This is going to be our r, and again, we have to put it into a decimal form, and this is our p. So now we plug that all in, and we want our future value. So that's going to be the future value. Now we're compounding of t, which is 7. And so we'll have our principal, 4,500 times 1 plus r, 0.039, over our n, which we said was quarterly, so that's 4. And then raised to the n, 4 times t, which was 7. Okay, so let me write this down, and we'll go over and get that into our calculator. All right, so now we have, that was the simple one. Now we're going to compound, so it's going to be 4,500 times 1 plus 0.039 divided by our n, which was 4, and then that's going to be raised to the power of 4 times 7 years, and so that should give us our value we need. So $5,904.73, 74 cents will go, because that's going to round that up. So let's move back over here. So that gives us 5,904.74. And again, we're going to use cents, so we rounded that 3/8 up to 4 here, okay? So that's going to be our future value on that investment with those given conditions. All right, so now let's go to the next one. All right, so here we're looking at returns on investment. And if you've ever looked, there's different ways they are going to show it. They're going to either show it as an APR, or they're going to show it as an APY. Now here, the new one is the APY. That's the annual percentage yield. And it looks higher usually, and because that's what happens is they're going to reflect the increase due to that compounding interest. So they're going to compound the interest, and it's going to increase. And so your APY is actually going to be higher compared to the APR. But what happens is we have a formula to get the APY versus just a plain old percentage rate, which is the APR. So the interest rate for loans are advertised in terms of the annual percentage rate, again, which looks lower because that ignores the increase due to compounded interest. So looking at them, The decimal form of APR is just the annual percentage rate, R, okay? Now that's the nominal rate. So that's what we have to remember, nominal rate versus effective rate. Some questions will say, hey, the effective rate is this, and you have to remember, oh, okay, now we're talking about the annual percentage yield, whereas the APR is just the nominal rate, and it's just the annual percentage rate in decimal form. And so the APY is going to be the yield, and it's given by this formula, okay? So it's 1 plus R over N raised to the power N minus 1. Because what happens is, when you get this, you might end up with 1.059, but, you know, we don't want the 1.059 because that's not going to give us a percentage. And so we're going to take off that 1, and we'll get basically the 5.9% or whatever percent we're looking at. Whereas maybe the APR was only 5.7%. Okay, but when we compound it, and again, I'm just making things up here just to kind of show you, this one will be lower than this one. Okay. So what we want to do is, on this one, it says a national electronics retailer offers a promotion of no interest for 6 months if the minimum payment is made each month and the entire amount is paid within the 6-month period. Now, if any of the terms of the payment are not satisfied, interest will accrue at 18% compounded monthly. So that's quite a high rate. Now, what we're going to do is purchase a home theater system with the 60-inch HD TV for $3,000, roughly $2999.99. Now, it asks, if you satisfy the terms of the purchase, how much interest are you going to pay? Well, it says you're going to get no interest if you make the minimum payments and you pay off the entire amount within that 6-month period. So part A, that's going to equal $0. Pretty nice. But again, you have to meet all the terms here. Okay, so that's the key. Now, the second one is, what is the APR? Well, it says we're going to accrue at 18% compounded monthly. So our 18% is going to be our APR. Now the APY, now remember, what we're going to do is, what we have to do is we have to take that 1 plus R over N raised to the N and then subtract 1, and that's going to give us our APY. So now, this one calls for a little work here, and so we have 1 plus our rate, 0.18, divided by our N, and so then we have to plug in the rate for that. And since we're doing monthly, the N is going to be 12. We raise that to the power 12, and then we subtract 1. Okay, so now we plug that into our calculator. And so we had 1 plus 0.1, not 0, 1.8 divided by 12 raised to the power 12. Now you have to remember to put that arrow back down, otherwise you're going to have the wrong number there, minus 1. And so we get 19.56 or 19.6% roughly. So this is going to give us 19.6%. Okay, so it's a higher number because it's considering the compounding interest along the way. And so it gives us that higher number. Okay, so 18% is the APR. No interest will be paid if we meet all the requirements, and the APY we calculated to be 19.6%. All right, so here we're going to save for the future. So how much money would parents of a newborn have to invest at 5% APR compounded monthly to accumulate enough to pay $100,000 toward their child's education in 18 years? So what do we know? Well, we know in 18 years is how long it's going to be. So that's our time. 5%, that's going to be our rate, and it's going to be 0.05. And what else do they give us? Well, they give us the future value. So they give us f of t, okay, or f of 18 if we want to put in that 18. So they give us a future value. So what is left? Well, we're missing the p. And so if we think about that, f of t was equal to p times 1 plus r over n to the nt. This time, we don't know that value. okay? So we can plug everything else in, 100,000, and then that equals P times 12, and we're compounded monthly, so that's our N is equal to 12. And then that's raised to the 12 times our 18. So what does that mean? We have to solve for P, so that means we're going to divide both sides by 1 plus, and then the same thing over here. All right, 18. All right. And so because if we do this in pieces, we're going to get a rounding error, I'm going to do this all in the one step. So we don't have to worry about, I rounded here, but did I not round here? What's going on? And so I always do these kind of problems all in one step. So we're taking the 100,000, dividing that by that 1 plus, and it was 0.05 divided by the 12, and that raised to the power 12, and then we had 18 years, and I believe that's everything we need. So we need to invest $40,733.06. So we go back over here, and this tells us P, how much we have to invest initially, is going to be 40,733.06. Okay. And again, we could plug in and do 1 plus 0.05 divided by 12, get enter, raise that to the 12 times 18, and then take whatever that value is and divide it into 100. But a lot of the times along those ways, you're going to have rounding errors. And so it's best just to type that whole piece in at one time, and then we have no rounding errors, and then we get our principal that we have to invest initially to get to that $100,000 in the future. Okay. All right. So that's all I have for this part. I'll come back in a little bit.